Hello, Augies Worldwide. I'm Dave Casler, amateur radio call sign KE0OG, here with another episode of Ask Dave. The comment today comes from Grover Larkins, N0GV, and it has to do with the fact that as you move an antenna up, you tend to create extra lobes on the top. His assertion is that it's worth it for the lower elevation angle for DX. So I've never done this, but I thought I'd quantify it. And let's see what we can do. I'm going to look at a 3-element Yagi on 20 meters, and it is at half lambda height, which I think is the optimum because you have a single lobe, 1 lambda and 1.5 lambda. Okay, so we can see what kind of lobes we get, how much power is in each, and so on. Let's take a look at these charts. This chart right here is a half wavelength high with 100 watts in the main lobe. So the effective radiated power, 100 watts is 50 dBm, plus you add the 12 dB of gain. So that's 62 dB going out at about 26 degrees. Now, the gain is down by half an S unit at this number here. Okay, so I'm just going to mark where that half an S unit is right here. Okay, which is about 12 degrees. If we go to 1 lambda high, okay, we've got 2 lobes. There's 67 watts in the main lobe, or 48 dBm, and 33 watts in the upper lobe, or 45 dBm. Okay, so in the main lobe here, we have 48 dBm, which is the 67 watts, plus the 13 dB gain, okay, is 61 dBm. Okay, note that this, although it went out higher, okay, is 1 dB more here, but here now we lose only a dB by pulling that down to here. So how do we compare this antenna with this antenna? Well, that low lobe is right there, but the lobe here on the main one, the 3 dB down, is 12.5 degrees. And here are elevations, 14 degrees. All right, so you are only losing 2 dB, not 3, but 2 dB here, because this is at the same angle as this right here. So they're almost equivalent. What happens up here? You've got a third of your power here. This is 3 dB down. Drop this by half, and when you spread out, you get 67 watts in the main lobe, 33 watts in the high lobe. So that's 45 dBm. It's down 5 dB from the full 100 with the 13 dB gain that you get here. I can see a mistake I made. Right now that's 10 dB. 56 dBm is correct. And a typo there. All right. So this is very important. This antenna, which gives you a lower main lobe, here you've got this big giant chasm here. Any signals that are coming in from this elevation angle are, let's see, 5, 10, 15, 18 dB. That's 3 S units lost. Okay? 3 S units lost. So this is one of the reasons I don't like going that high. Yes, you lower this lobe, that might get you some DX, but you lose a bunch right here. Whereas with the original, okay, you're only 3 dB down way up here. Okay, so this is quite a few dB down. This is just 3 dB down from the max gain of the antenna. Let's look now at the case where we're at 1.5 lambda. Okay, we get 3 lobes. The lowest lobe is way down here at 10 degrees. That's great. But then again, okay, you lose all this stuff in here and here, okay? Whereas the half lambda antenna will pick up the stuff coming along here, which is along here, is only down by 3 dB. Here it's down by, well, close to 18 dB, okay? And this is down by over 20 dB. So that's 3 to 3.5 S units down. Now let's compare these now, see what we've got. And I'll put them kind of side by side. We're not interested in the back lobes. So we'll just look at the frontal lobes. In this case here, a 10-degree signal would be just 3 dB down from 62. Here the 10-degree signal is, instead of 58, is 61. So yes, you've got a little bit of gain for this going really low. But you lose a lot in this null. Okay, that's 3S unit null. And then if you have something coming in this height, you pick it up. But here, we see that it is only 3 dB down again. So we're still getting a much better signal right there. And on this one, you've got these two great big nulls. So I guess you pays your money and takes your choice. Now, if you are a really ardent DXer, you would make a 100-foot tall tower, put a 3-element beam here, a 3-element beam here, and a 3-element beam here. And at the 33 feet, the 67 feet, and the 100 feet. Okay, now, what does that do for you? You can pick the antenna that you want to get the DX, because this antenna gets these, but it doesn't get as much the real low or the real high. But this one, which is this antenna here, has a lobe here, but a lower here. And this one at the top, you've got 2 lobes. So you switch back and forth between antennas very quickly. You'll have to run 3 coax or put some relays up there. But the point is that you can choose an antenna. Now this is for the really rich DXer that they would do this. A lot of people just put it up on the tallest tower that they can afford. They're going to get something in between here and here. Okay, if I were to put up a 20-meter beam, I think I'd put it up about 35 feet and just leave it go at that, because that'll give me this kind of a pattern where I don't have the big nulls that come in here. Now note, for an antenna like this, if you've got a signal coming from almost directly overhead, your 15 dB, that's 2.5 S units down for the ones that come at a real high angle, okay? Which will not be much different than here. You've got a little bit more there. So they're different. Which one is better? Well, there are a number of things to consider. If you're just going out for a big chunk of the sky, okay, then probably the half lambda height, a 35-foot tower, would be just right for you for a 20-meter beam. Now notice you run into the same problem now on 10 meters, okay, because these things scale. So at 10 meters, you've got the thing up at a full lambda, and your 15-meter beam will be somewhere in between. So that'll give you an idea of the kinds of things that are going on. By the way, the beam sample that they included in Easy NEC has pretty high SWR at the measurements. You're going to have to match the antenna. The antenna is about 100 ohms at the feed point, and it's got a pretty big reactive component. So you'll need a gamma match or something like that to get the thing. You can't just directly connect the wires to the 2 halves of the driven element. You're going to need a matching network of some kind. You can do that in a variety of ways, but that's beyond the scope of this video. So the net of what we've learned today is that as you raise an antenna, you lower the lowest lobe down toward the horizon, but less of the transmitter power goes into that lobe because that power is wasted in other lobes. You can get the thing down really far, but there's not a lot of power behind it that may enable you to get a juicy DX station in Africa or whatever. Depends on the propagation. A 100-foot tower, people think that's great. And yeah, they talk to lots of people. Really, they do. But there are a lot of people they don't talk to that fall into those lobes. So, pays your money, take your choice. I recommend the half wavelength as an optimum height for the antenna. When you've got multiple bands on one tower and multi-band beam, you're going to run into different patterns on different bands. So just something to think about. If you'd like to help support this channel, check out our patreon.com link. And until we next meet, 73.